Alright, this is 8.9, direct variation. It's the last section in the chapter. Alright, I don't know how familiar you are with direct variation, but it definitely warrants some review. And we'll try to make this as simple as possible for you. So let's talk about how many shoes we're wearing in class. So there are 11, there's 10 students. We'll just go by students. How many shoes are the students wearing? There's 10 students, so we have to figure out how many shoes they're wearing. So you can count by twos, and the number of people multiplied by 2. So there are two different ways to kind of figure out how that would work. Now we have to assume that they're wearing shoes and assume that we have 2 feet per person. And we're going to have to assume that there are 2 shoes for each person. So if that's true, this is very simplified, and there are 11 of us in the room, 10 students. So 10 students would have 20 pairs of shoes. What would that mean for 11 if you included me? That would be 22 pairs of shoes. So what we're finding out is that as the number of people goes up in the room, the number of shoes goes up in the room at the same rate. Okay, that's the key part. It's going up at the same rate. So as the number of people go up, the number of shoes go up at a constant rate. A direct variation is a function. That's what we're studying right now. A direct variation is a function expressed by y equals k times x. And we're going to talk about how this relates to shoes and constants and rates in a second. So just get this down. Direct variation is a function expressed by y equals k times x, where k is a constant called the constant of variation. Where k is a constant called the constant of variation. A constant is a number or value that doesn't change. So when we're doing our example, let's look at a chart. Alright, and let's fill in some numbers here for people and shoes. We'll say people is x and shoes are y. If we have 0 people, we have 0 shoes. 1 person would be 2 shoes. 5 would be 10. 14 people would be 28. 15 would be 30, and we could keep on going. But you get the basic idea of how to get that. Okay? So if we charted this, you could see I've already did a little bit of a graph over here. Oops. Okay, and plotted some points, 0, 0, 1, 2, 5, 10, and you can see they're all in a straight line, and they would continue to go in the straight line. So when you have a direct variation equation, you're going to get a straight line, and they're all increasing at the same rate. Now, what is that rate? Well, the rate, okay, that constant rate is the same thing as the slope. So we can have a numerical representation by doing like these charts. We can have a graphical representation by drawing it out, and we can come up with this constant rate. All right. Now, in your head, you know what that rate is. What's that number that you need to have every time when you're multiplying by people to figure out the number of shoes? It's 2. All right. So 1 person times 2 would be 2 shoes. 5 people times 2 shoes would be 10 shoes. 14 times 2 would be 28. Okay, so that K now for over here is 2. That is our constant rate. Let's go over to the graph. Let's look at these points here, okay? If we go right, 1, 2, 3, 4, excuse me, that would be on the bottom. We got the run, I should have done it the other way first, it's okay. And then up would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 4 would be our rate, which is 2. So our rate is, or K is 2. And so our equation would be that Y varies directly with X with a constant of 2. Alright, so now I've got a little equation. I could just put in 100 here for students, and when I got out the answer, I could get, by multiplying it times the K, I could get how many shoes I would have. Okay, very simple version. I hope that kind of gives you an introduction to what we're talking about with the rates. Okay, so given that Y varies directly with X, alright, you need to write this down, and that Y is equal to 12 when X is equal to 48. Okay, so what we're figuring out, they're asking us a few questions. So they told us that it's direct variation. So when we see that it says Y varies directly with X, immediately we should say, okay, we know that the relationship is going to be this. Okay? When I see that Y varies directly with X, it's going to be this equation. Now it could say, given that R varies directly with P. Okay, if R varies directly with P, then I would have an equation that looks like this. So the variables don't really matter. What really matters is that when we say it varies directly, it's in this relationship with a constant. So that's all that first sentence means. And then they tell us that Y is equal to 12 when X is 48. Okay, so that's helpful information because the next step is they want us to find K. Well, look at the ordered pair we have, 48, 12. Okay, that is an ordered pair that we can say is X and Y. Here's our direct variation equation. And so to find K, we just fill in the values. So we have 12 is equal to K times 48. And we can solve that by dividing both sides by 48. So K equals 12 over 48, which is 1/4. So K is 1/4. Just like when we did our shoes, K was 2, right? So now it asks me to write the equation. Well, if K is 1/4, we want to say that Y is equal to 1/4 times X. Because Y and X are going to change. The number of people in the room are going to change. The number of shoes in the room are going to change. But remember, 2 was always the same. That rate. So 1/4 is always the same. This is the equation that we can use for all situations, just like when we had different numbers of people in the room. So when I go down here and the next question says find Y when X is 3, excuse me, I now have an equation to help me. So it says find Y when X is 3. Well, Y would be 3/4. Okay, simple enough. All right, this is from the book, page 394, number 11. They're giving us ordered pairs. They're saying XY, X1, Y1, and X2, Y2, just meaning two different ordered pairs, are of the same direct variation, meaning like they have the same K. All right, so X1 and Y1 have a K, x2 and y2 have a k, and they're the same. So we need to find each missing value in what they have down here. Okay, so they've given us some examples of some points that are on that page. So we know that both of these have the same k, because that's what it told us in the question. So when I do this, now in the first one, in the x1, y1, I have both of the coordinates, so I could find k. Alright, so the strategy then becomes, if I know this k, then I will know the k for the next point, and then I will be able to solve for y even with just one point. So in the first one, I can say that 9 is equal to k times x. Excuse me, not x. 9 is equal to k times 15. And we divide both sides by 15. So k is going to equal by 3/5. Alright? Now, since same k, I'm going to put 3/5 over here, because that applies to both. And now when I work the second problem, I'm going to say, alright, I know that both of these equations, this has to be true. So if I want to solve for y, I can say y2, I don't know what that is equal to 3/5 times 40. Alright, and I'm going to cancel that. It's going to be 1 and 8. 8 times 3 is 24. So y2 is 24. Okay, so I'll show you a couple different examples. I hope that makes sense. You can think back to that shoe problem. It always kind of helps keep things in perspective. Alright, so bring those notes for me on Tuesday.